Okay, we are back to notes again today. So we are doing notes number 2 for our last unit of the semester. Last week we went through notes number 1 on simplifying radicals, so how to take a square root that's not a perfect square and simplify it by taking out all of the perfect square factors. If you had questions on that or anything, let me know, but I will be doing an optional live class on Thursday, and that'll be a good chance for you guys to come and ask questions if you've got them. So if you're struggling with this stuff, make sure you show up for that live class and we'll go through several questions, or at least just send me a message. You have to communicate with me if you need help, okay? Okay, so today we're going to do a little more with simplifying radicals, add on some extra rules, some other things we're going to see. So here we've got these 3 kind of guidelines here to decide if we've got something completely simplified. The first one is what we did on notes number 1. That is simplifying a radical. So the number inside the radical, the radicand, should have no perfect square factors left other than 1. That's what we did in notes number 1. The second, there should be no fraction inside the radical. And finally, there's no radicals in the denominator of a fraction. That's actually a process called rationalizing the denominator, and you'll see how to do that today. And it's, again, a very commonly accepted mathematical thing we do. Seems like it doesn't have a purpose, but it's just what we do in the math world, and you're going to see it, so you need to make sure you understand what's happening there. It's a lot of stuff on sometimes on standardized tests and such. Okay, so let's get to some examples here and see how these work. Oh, but before we start, let me also say that no matter what you do, always check for perfect squares. Okay. I notice in this unit a lot of times people will start doing the factor tree thing, or they'll start doing all of these things, but it's always simpler if you can find a perfect square and simplify that first. So always check for perfect squares first. That will save you a lot of work and time sometimes. Okay. Let's say first. And you won't always have one, but it helps. Okay, so number 1, so like I just said, we're going to check for perfect squares first. So 32 is not a perfect square and 2 is not a perfect square. Can't do anything with that. Okay, now 32, I could do my factor tree like we did in notes number 1, but I also noticed something else here. The 32 and the 2 are separated into 2 different radicals, and it's division, right? Because they are both inside of a radical, we can actually do that division. You can kind of think of it as rewriting this all in one fraction. We had this property on our notes last week. You can take those separated radicals and put them back together. Now, the point in doing that is the 32 divided by 2, that division is doable, and it ends me with an integer rather than a fraction. So that's kind of nice. So we can switch this to just say 32 divided by 2. That is just 16, right? But I have to keep it inside the radical because it was inside the radical to start with. And then the square root of 16 is 4. Ta-da! And there's our answer, right? Okay, so if they're both inside the radical, you can actually go ahead and divide those 2 numbers and then just get your result inside the radical and simplify that. Okay, next one, number 2 over here. Again, we've got some fractions inside of radicals. So first, I'm going to check for perfect squares. 3, 7, 14, 27. None of those numbers are perfect squares, so I can't do anything with that. Then I'm going to check to see if I can reduce the fractions. 3 over 7, not reducible. 14 and 27. 14's only factors are 2 and 7, and neither of those go into 27. So we can't reduce either of the fractions. So now my only step is I don't want to leave a fraction inside a radical, so I'm going to split those, kind of doing the opposite of what we did in number 1. So I'm going to rewrite this as a radical 3 over radical 7 times radical 14 over radical 27. Okay, and then it's very, very similar to doing any fraction multiplication problem. If I just took the radicals away and said did 3/7 times 14 over 27, is that right? I don't know. Anyways, you would cross cancel, right? You would say 3 is 1, 27 is 9, and then 1 and 2, and you multiply and get 2 9s, right? We're doing exactly the same thing. It's just that everything's inside a radical. So because everything is inside the radical, we can cross cancel just like I just did, right? So the 3 and the 27, that would reduce to radical 1 and radical 9, right? And then I can do the 7 and the 14, and that become radical 1 and radical 2. And if we multiply those across, then we'd end up with radical 2 on top and radical 9 on the bottom. Okay, now again, before I go to try to simplify perfect squares, radical 9, that's a perfect square, right? The square root of 9 is 3. Make sure that radical goes away because we actually did the operation of taking the square root. The square root of 9 is 3, not radical 3, 3. And then on the top, we end up with just radical 2. So now I can check radical 2. I can't simplify any further. There's no fractions inside of my radical, and I don't have a radical on the bottom. So this is my simplified result. Okay. All right. Next up here, we've got some multiplication with radical expressions. So here, notice that we've got numbers on the outside of the radical and numbers on the inside of the radical, right? So we kind of have to treat those separately. Sometimes I tell people, like, if you're doing 3x times 4y, we typically do the numbers first. So 3 times 4 gives us 12, and then x times y is xy, right? Kind of the same thing here. So I'm going to look at the outside numbers first. 3 times 4, that will give us 12. And then I can do the inside numbers. So radical 2 times radical 18 would give us radical 36, right? So then if I take the 12, radical 36, that's a perfect square, right? The square root of 36 is just 6. This is 12 times the square root of 36, so that would end up as 12 times 6. And then 12 times 6 gives us 72. Okay, so when you're multiplying or dividing radicals, the important parts to remember are you can multiply or divide outside numbers, and you can multiply or divide inside numbers, right? Oops. You never want to divide them if one's inside, one's outside, or multiply, okay? All right, so now let's look at one where we kind of ran into that problem. And next one, we've got 3 over radical 5. So this is kind of what I was talking about. The 3 is not inside a radical. The 5 is inside a radical, right? So I can't actually divide those two numbers because one's in a radical and one's not. And either way, 3/5 doesn't reduce. So that would get us nowhere anyways, right? So we're kind of stuck here, but we do have a problem. We have a radical in the bottom, right? So since we have a radical in the denominator, we need to get rid of it, right? So this is the one where we're going to see what it means to rationalize the denominator. Basically, it means we're going to make the denominator a rational number because right now it's an irrational number and I want it to be rational, okay? So we are going to take our 3 over radical 5, and we can always take a fraction and multiply it by some form of 1, right? Just like if I take 2/3, I can multiply it by 2 over 2, and I get 4/6. The 2/3 and the 4/6 are equivalent because we're multiplying this by this form of 1, right? So I'm going to do the same thing here, but I want to do it in such a way that I get rid of the radical on the bottom. And what undoes a radical? Well, undoing a radical, if I square it, then I would get rid of the radical. So if I were to multiply the denominator by radical 5, then that would give me on the bottom radical 25, and the square root of 25 is 5, right? So now if I multiply the bottom by radical 5, then I also need to multiply the top by radical 5. That way I'm multiplying by that form of 1, right? So then 3 times radical 5. Now here, I can't do 3 times 5 and get 15 because the 3 is outside, the 5 is inside. So I'm just going to leave it as 3 radical 5, right? And then we just keep it the same way, 3 radical 5 on the top. And now, be careful here. I get people sometimes who want to cross out those 5s because you've got one on top, one on bottom, but you should kind of be saying to yourself, no, Miss Mac, you can't do that because one's inside a radical and one's not, right? So that would be my final answer. I can't reduce the 3 and the 5 here. I could do some division, but there's no reducing there that can happen. So that's my final answer. Okay, that's rationalizing the denominator. That's what that looks like, is taking a fraction that has a radical on the bottom and making it not have a radical on the bottom. But if you typed 3 divided by radical 5 in your calculator, and then if you typed 3 times radical 5 divided by 5 in your calculator, they would give you the exact same decimal. They're equivalent. Okay. Okay, number 5. Kind of the same idea here. First thing I notice is I've got a fraction. Neither of those things are perfect squares. That's what I want to check for first, right? So if neither of them are perfect squares, I might check to see if I can reduce the fraction. 7 over 8, I can't reduce that. So I'm going to go ahead and split this and make it radical 7 over radical 8. Okay. All right, so then the next thing is I notice I've got a radical on the bottom, so I want to rationalize that. But if you would like to, you can actually simplify this radical before you rationalize it, right? Radical 8, I can simplify a little bit. I'll do it the factor tree way first, and then you can also think of perfect squares here. But if I break down 8, that'd be 2 and 4, and then 4 is 2 and 2, right? So remember we talked about, we're then going to write out our prime factorization here. So I'm going to keep the radical 7 on top, and then I've got 2, 2, 2. And remember, you want them in groups of 2s because we're doing the square root. So I'm going to make this 2 squared times 2, right? And then I'm going to keep my radical 7 on top. And on the bottom, the square root of 2 squared, that's just a 2. So that comes on the outside. But the other 2 that's by himself has to stay on the inside. Okay, so if you would like to simplify that radical first, sometimes that makes the next step a little bit easier because now I have to rationalize, right? So my next step is going to be to rationalize. So I'm going to take my radical 7 over 2 radical 2, and I need to get rid of that radical on the bottom, right? Now, the 2 on the outside is totally fine. That can stay in the bottom. I only need to get rid of the 2 on the inside. So all I need to do is multiply by radical 2 on top and bottom. So then on the top, 7 times 2. Now this time I can multiply these because the 7 and the 2 are both inside the radical. So I end up with radical 14. On the bottom, the 2 is going to stay as a 2. And then radical 2 times radical 2 would give me radical 4. Right? 4 is a perfect square. That's the whole point of rationalizing here. So I'd end up with radical 14. And then this would be 2 times 2 because the square root of 4 is 2. So I'll get radical 14 over 4. And again, remember the 14 and 4 I can't reduce because the 14 is in the radical, the 4 is not. So I have to stop there. That's my simplified and rationalized radical expression. Okay. Now you could have decided to rationalize first. That's totally fine. If you rationalize first, then you just have to simplify after you rationalize. So again, this is kind of like when we did exponent rules and such. There are different ways to go about getting these finished. I'm just showing you the way that's the most logical to me. Okay. Okay, one more here. I've got 9 radical 3 over 24. Okay, again, the first thing I'm always going to do is check for perfect squares. 3 is not, 24 is not. Neither of those are perfect squares. My next step is I look at the fraction. So I have a 3 inside and I have a 24 inside. I can actually reduce that, right? 3 and 24 are both divisible by 3. So I can divide both of those by 3. And that will land me with 9 radical 1 over radical 8, right? The 9 stays exactly the same because it's outside the radical. I'm only reducing the numbers that are inside, right? Because they both have to be inside to be able to do that division. You kind of think of this as 9 times radical 3/24, if you want to think of it that way, right? Okay, and then the square root of 1 on the top, that's just 1. So then I end up with 9 over radical 8. Okay, and then we're kind of in the same exact boat almost as our last problem, where we've got a radical on the bottom. So I'll tell you what, this time we'll rationalize first, just to see what that looks like. Okay, so I'm going to rationalize, oops, let's actually write that over here. So I'm going to rationalize first this time. Okay, so we've got 9 over radical 8. To get rid of that radical, I'm going to multiply by radical 8 over radical 8. Whatever's inside the radical, that's what you multiply by. On the top, the 9's outside, the 8 is inside. I can't multiply those two numbers, so it just stays 9 radical 8. And on the bottom, radical 8 times radical 8 is radical 64. And the square root of 64 is 8, right? 9 radical 8 over 8. Okay, and now a lot of people will be like, oh, I'm done because the 9 and the 8 I can't simplify, but I can simplify that radical 8. So we need to do that. Okay, so now we're going to take our radical 8 and simplify it. Some of you may remember we also looked at, since we did it by the factor tree method up in the last problem, radical 8 is the same as radical 2 times radical 4, right? And radical 4 is a perfect square. So radical 8 would actually equal to radical 2, right? Okay, so that gives us 9 times 2 radical 2, because that's what radical 8 was, over 8, which would give us 9 times 2 I can do because those are both outside the radical, so 18 radical 2 over 8. Okay, and then one last step, the 18 and the 8 are both on the outside of the radical, and those are both divisible by 2, so now I can reduce that part. So I'm going to get 9 radical 2 over 4. If I divide the 18 by 2, I get 9. Divide the 8 by 2, I get 4. Right? Okay, so a couple different ways to do those problems. You can sometimes rationalize first and then simplify. You can simplify first and then rationalize. I tend to always go with the simplify first and then rationalize. Usually it ends up that you do less work that way, but sometimes it doesn't. So it just depends. You kind of pick which way you want to try it both ways, see which way you like better. Just depends on the problem, what's going to go the best. But as long as you're doing the steps correctly, you'll eventually get to the correct answer. Okay? All right, so homework number 2 is again on OneNote today. And again, you're doing that on paper and submitting or uploading that to OneNote. We want to make sure we can see your steps, so make sure you're showing your work. That will give me kind of a good clue on Thursday for our live class what problems we need to go through. So at least try to get your homework 1 turned in today and this one started, or if you can get it finished before class Thursday, that'd be great, even though it's not due till the end of Thursday. But that way we've got some questions to go over. Okay. All right. Have a good one, guys. I will see you, hopefully, or some of you, on Thursday.